Hi guys, let's look at the next set of questions. Next question is question 7. It says write a pair of irrational numbers whose sum is irrational. So let the first irrational number be 3 plus root 2 and let the second irrational number be 2 plus root 2. So the sum of these is 5 plus 2 root 2, which is irrational. Let's look at the second question, or rather the question number 8, which says write a pair of irrational number whose sum is rational. So let's look at 3 plus root 2 as our first irrational number and 2 minus root 2 as our second irrational number. If we take the sum is 3 plus 2, which is 5, because negative root 2 and plus root 2 gets cancelled. Question number 9. A pair of irrational numbers whose difference is irrational, which means 3 root 2, let it be the first irrational number, minus root 5, let it be the second irrational number. The answer is 3 root 2 minus root 5, which is irrational. Let's look at the last question on this slide. Question 10. Pair of irrational numbers whose difference is rational. Let's look at 3 plus root 2 as the first irrational number, and let's look at 2 plus root 2 as the second irrational number, and what we have is 3 plus root 2 minus 2 minus root 2. Root 2 and root 2 gets cancelled. This is 1, which is a rational number. Let's look at the next question. The next question we do is question number 11. We need to look at a pair of irrational numbers whose product is irrational. Let root 3 be the first one and root 2 be the second one. This is equal to root 6, which is irrational. Next, pair of irrational numbers whose product is rational. Let's look at root 3 multiplied with root 3, which is equal to 3, which is rational. Next, let's write it in ascending order. So if we need to compare irrational numbers, we should look at the same form. So in this case, this is number and some part is in the square root sign. So let's take 3 inside the square root sign. So this would become 3 into 3 into 5. That's the first number. And the second number is 4 into 4 into 3, right? So this becomes 3 into 3, 9 into 5, 45. So the first one is square root of 45 and the second one is 4 into 4, 16 into 3, 48. So if I have to write it in ascending order, root 5 is less than root 48, but these are not the numbers given. So this would be 3 root 5 is less than 4 root 3. Next one. In this case, the power is different. In this case, the power is the same. Sorry. So this is 2 root 2 multiplied with third root of 5 and 3 multiplied with third root of 2. So let's take 2 inside. So this is 2 into 2 into 2 because this is the third root multiplied with 5. That's the first number. And the second number is 3 into 3 into 3 multiplied with 2. And this is the third root. So the first number is third root of 248 into 5, 40. And the second number is third root of 3, 9, 27, 54. So third root of 40 is less than third root of 54. So we will write it in the form it is given in the question. 2 times third root of 5 is less than 3 times third root of 2. Last one, 6 root 5, 7 root 3, 8 root 2. Let's take them inside. So this is 6 into 6 into 5. The second one is 7 into 7 into 3. And the last one is 8 into 8 into 2. So this is the first number is 30 into 6. That's 180. The second number is 21 into 7. That's 147. And the last number is 64 into 2. That's 128. So if I write it in ascending order, that would be 128 root is less than 147 root, which is less than 180 root. Let's write it in the form it is given in the question. So 8 root 2 is less than 7 root 3, which is less than 6 root 5. That's my final answer. Let's look at the next one. The next one that we do is question number 15. So in the previous question that we did, the root was the same. So in this case, it's the sixth root. In this case, this is the fourth root. So let's write it in the exponent form. This can be written as 15 raised to the power 1 by 6, and this can be written as 12 raised to the power 1 upon 4. So the objective would be to make it in the same root. This is the sixth root, this is the fourth root. Let's take the LCM. So the LCM of 6 and 4, that's 12, which means I can write this as 15 to the power 1 upon 6 into 2 upon 2 in case I want to make it the LCM equal, which means that will be the 12th root that we are looking at, and 12 raised to the power 1 by 4 into 3 upon 3. This becomes 2 upon 12th root of, rather 15 raised to the power 2 by 12, and this becomes 12 to the power 3 upon 12. This can be written as 12th root of 15 square, and this can be written as 12th root of 12 cube. Of 15 square is 225, so this is 12th root of 225, and the second term is 12th root of 12 cube. 12 cube, that's 144 multiplied with 12, that's 882, 441, 8, 8 plus 4, 12, that's 1728. So that's obvious, 1728. Now, once we've made them into the same root, what we realize is that 12th root of 1728 is far more than 12th root of 225. So we can write this as 6th root of 15 is less than 4th root of 12. Next question, root 24 and third root of 35. Again, let's make the power equal. In this case, this is the second root, which means I can write this as 24 to the power 1 upon 2, and this can be written as 35 to the power 1 upon 3. LCM of 2 and 3, yes, that's 6. So I will multiply this with 3 and divide this by 3. I multiply this with 2 and divide by 2. So this will become 24 raised to the power 3 upon 6, and this is 35 raised to the power 2 upon 6. So this is nothing but the sixth root of 24 cube, and this is sixth root of 35 square. 24 cube, that's 24 into 24, 4 into 4, 16, 96, 2 into 4, 8, 2 into 2, 4, 6, 9 plus 8, 7, 576 into 24, 6 into 4, 24, 28 plus 2, 30, that's 20 plus 3, 23, and this is 2 into 6, 12, 14 plus 1, 15, and 10 plus 1, 11. This is 4, 2, 8, 3, 1. So this is sixth root of 13824, and this is sixth root of 35 square. 35 square would be 3 into 4, that's 12, followed by 25. Now it is very obvious this term is less than this term, which means third root of 35 is less than root 24. Done. Let's look at the next question. The next question that we have is question number 16. Question number 16 says, insert two irrational numbers between 5 and 6. Now, since we're talking about irrational numbers, which means we're looking at roots which do not have exact value. So 5 is nothing but root of 25, and 6 is nothing but root of 36. So irrational numbers between 5 and 6 would be root of 26, root of 27, root of 28, and so on, going up to root of 35. We need to insert 2, so we can look at root 26 and root 27. Next, let's look at inserting 5 irrational numbers between 2 root 5 and 3 root 3. Exactly a similar question as 6. So 2 root 5 can be written as 2 into 2 into 5, which is equal to root 20, and 3 root 3 can be written as 3 into 3 into 3, that's root 27. So numbers between 2 root 5 and 3 root 3 would be root 21, root 22, root 23, root 24, root 25, no, not 25, because 25 would become 5, root 26. Yes, the root 25 will become 5. So this is root 26. So these are 5 irrational numbers between 2 root 5 and 3 root 3. Next question, write two rational numbers between root 2 and root 3. Now root 2 we know is approximately 1.414 and root 3 we know is approximately 1.732. So any number between these two numbers would be a rational number. So let's look at 1.5, 1.6 and 1.7. I'm looking at just 3, but 1.5 is not a rational number. So let me just convert this into 15 upon 10, 16 upon 10 and 17 upon 10. Still, these are not rational numbers. This is 5 into 2, 5 into 3. So the rational numbers are 3 upon 2. Next, this is 2 into 5, 2 into 8. So this is 8 upon 5 and this is 17 upon 10. So I've inserted 3 rational numbers between root 2 and root 3. Next, 3 rational numbers between root 3 and root 5. Similar logic, root 3 is approximately 1.732 and root 5 is approximately 2.23. The numbers between these would be 1.8, 1.9, 2, 2.1, 2.2. I have inserted 5. Again, this is not rational yet. Let's just write it as 18 upon 10, 19 upon 10. 2 is directly a rational number. 21 upon 10, 22 upon 10. Let's simplify. That's 2, 9, 2, 5. So 9 by 5, 19 upon 10, 2, 21 upon 10, and this will be 11 upon 5. So again, I've inserted 5. Simple calculations. And let's look at the last question of this exercise. The last question of this exercise is question number 20. So it says simplify. Now we have fifth root of 16 multiplied with fifth root of 2, which means this is nothing but fifth root of 16 into 2. And we know 16 into 2 can be written as 2 into 2 into 2 into 2. That's 16, 4, 16, and then the last 2. Since this is the fifth root, we need groups of 5. So out of these group of 5, one number comes out. The answer is 2. Next question. Fourth root of 243 divided by fourth root of 3. This is nothing but fourth root of 243 upon 3. At 381. So the answer is fourth root of 81, which is nothing but 3. And the next part of the question, 3 plus root 2 multiplied with 4 plus root 7. This is basic multiplication of binomials. So this is 3 multiplied with 4 plus root 7 plus root 2 multiplied with 4 plus root 7. Let's multiply. 3 into 4, 12 plus 3 root 7 plus 4 root 2 plus root 2 into root 7. That's root 14. And there is nothing else that we can simplify it further. That's my final answer. Let's look at the next question. That's root 3 minus root 2 whole square. This is in the form x minus y whole square, which is equal to x square plus y square minus 2xy. So in this case, that's root 3 whole square plus root 2 whole square minus 2 multiplied with root 3 multiplied with root 2. So this is 3 plus 2 minus 2 root 6. So the answer is 5 minus 2 root 6. Done. That finishes this exercise for me. Take care, be safe. I'll see you with the next video. Bye bye.